Hello guys, welcome back to the video, and in today's video we are looking for a new topic of enzymes, that is the enzymes theories, like theories of enzyme action. And in previous video we have been discussing about the enzymes introduction, uh, the properties and the characteristics. If you haven't checked out that video, do check that out. And by today's video looking for the theories of enzyme action, like what does this mean? We are looking for enzymes action, like enzyme, it's action, whatever it does we are looking into the theories for that, like this means that enzyme action is still under study. Like if you've got theories, we have got no laws according to it. And there are two main theories. For today's video we are looking for one of them. And these the first one is key and lock theory, which we are studying today, and the second one is induced fit model. The both theory are 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 you know they have been seen being applicable at different places, so we cannot justify any one of them wrong. So it's all under study right now, and we are studying this. So without wasting time, let's start our video. Okay. uh, as the name says, that lock and key model, there's something related to lock and the key, and we are relating it both to the enzyme in the form of a model. So this is gonna be fun. First of all, let me you know show you the diagrams for that you may get an idea what we are discussing today. This is a key, and this is lock. A lock is an enzyme. Always to remember this. Lock is always an enzyme. And this may be asked in MCQs, that what is lock in the lock key model. So you have to say that this is enzyme and key is a substrate, and the key is attached to this lock, and this thing is formed in the same way. Over here, the enzyme is here as a lock, and we've got active side. We have discussed in our previous video that enzyme has got two sides. One is active side and one is allosteric side. The active side is the one where the substrate attaches, and the substrate is acting as a key over here. You will see the pattern, which it will get fit to it. It will just get it fit into this, and the thing will take place. As you can see that the key is fit, and the key lock key complex is formed, like both lock and key is here. In a similar way, we have got this one attached, and what is formed is the enzyme substrate complex. Now this is the term which is said to be junction of the enzyme and the substrate. And this is also asked in MCQs or in questions, like what is enzyme substrate complex. So this is a stage at which the enzyme is attached to the substrate. Yes, let's move forward. uh, Lock and key model. Now lock and key model of enzyme action proposed earlier this century. They proposed earlier, and simply drawn substrate was simply drawn into a closely matching cleft on enzyme molecule. Now, what does this statement mean? Like, for suppose I have got enzyme for this structure, this is my enzyme, and here is a place for this is active site, and here I'm finding some sort of substrate to fit in. So according to key and lock model, if I've got two substrates over here, one is of this shape, one is of this shape, and second one is of this shape. Now these both are substrates, two different substrates. Now what do you think will fit into it? Now as we are applying the uh, lock-in key model over here, so this one will be going in this place. So this is all lock-in key model. It says that the specific substrate is junctioning within a specific enzyme. Here the statement also means the same. Okay, the same diagram. Yes. When it is attached to it, in the result, uh, uh, enzymes are performing catalytic action. So the breakdown or the products are formed, and you're gonna see that they have been cutted beside both, and these are the products. This is product. This is product. So these are also similar with the active site, right? Active site. Sorry. Uh, a substrate drawn into active sites and substrate must come. Oh yes, we are done with it. Okay. The substrates on which enzyme act are called substrate. The substances on which the enzyme act or substrate we are done with it. Uh, Enzymes bind to substrates by lock and key hypothesis. Now, this is a partial statement, while we can also say that enzymes bind to substrates by the uh, reduced fit model. We are not discussing what is that in this video. We'll probably discuss that in the next video. Okay, this is the same. Let me look for some important points. There are some. Okay, this means that I just told you before that this means that the conclusion is that a specific substrate binds to a specific enzyme, and uh, that one is termed to be as absolute specificity. And here I've just in the last video I just missed a point. I would like to include that as well. That enzyme name was coined by W. Kone. Enzyme name was coined by W. Kone. While uh, this model has been presented by uh, Paul Fielder and D.D. Woods. Paul Fielder, just mentioned it. Paul Fielder and D.D. Woods. These both scientists presented this theory or model. D.D. Woods, right? So I do hope that you got the concept. In the next video, we'll discuss the induced fit model. So meet you guys in the next video. Till that, goodbye.